Hello grade 12s, we are going to do object-oriented programming, question number 3 of your exam papers, and we have to open a main program, and we also have to open the unit. So your main program is this, and then you've got to go file and open, and make sure you open the unit.pas as well, and then take note there's a data, but there's a text file there as well. You can open that and look at that. So I've opened the unit already. Take note, you have to put in your name or exam number. In the case of final exams, put your examination number there in both the units, your class definition unit and the unit for your main program. So let's go and look at our question. Oh, and here's the text file. And you can see we have a separator of a comma and then a hashtag. It's just getting to know our files that we need for this program. Now, it says here, right, so we have a delivery trip system, deliveries between different cities in South Africa. The program determines the type of truck required for a delivery based on the weight of the load. Sorry about that. So let's look at our class definition. Incomplete object class. We have 5 attributes. There they are: F trip number, F departure, F destination, F load, F distance, and it gives details of what those all are. Accessor methods: get departure and get destination. Accessor is a function, remember, and then the toString method, which will be a function as well, and then an auxiliary method, which is a private method of the class, because it works on the attributes of the class, sets the private attributes of the class. That's why we call it an auxiliary method. So we will then go and look at the instructions. Complete the code for the private method called compile trip num that will return a 3-digit randomly generated number that does not end with 0. No zeros at the end of that 3-digit randomly generated number. So you got to generate a 3-digit random number, but it must not have a 0 at the end of it. So that means we will have 3 separate digits randomly generated, but the last one must not include 0. If a method returns something, then we know it's a function. So let's go and look at our compile trip num function. There it is. Returns an integer and must be 3 digits, which are randomly generated. And we're going to use this variable called iTripNum, which will eventually be an integer that will be returned. So our result will be iTripNum. At the end of all of our workings out, say result colon equals iTripNum. Remember, at the end of a function, you always have to return a result. So that is, but we first have to compile this iTripNum using the instructions that they give us. 3 digits, randomly generated. So what I'm going to do is I'm going to generate 3 separate random numbers from 0 to 9, except the last one must not be a 0. I'm going to actually make them strings. S num1, S num2, num3. Now you wonder why, because I've got to join them together. So S num1 will be equal to int to string. Why? Because I'm going to use a random number, random range, and convert that number to a string. I can make it 1. It must be 1. And the upper level must be 9, but you use 10 for random range. And of course, yeah. So that's my first digit, and the second one will be the same. There's 2, and then the third one is num3. Must have a different range, not from, well actually this number 2 can be a 0, can't it? But number 3 must definitely be from 1 to 9, but we don't want the first digit to be a 0. You can't have 0, 1, 3 or 0. So we have our 3 strings. So I trip num will be equal to int to string, string to int, sorry, string to int, and s num1 join to s num2 join to s num3. So that is the way I would go about it. And just run to make sure it compiles. So it compiles. Don't forget during the course of your program that you always save, file save all. It's only 4 marks. So maybe there's another way to do it, but that's the way I was going to do it. I'm sure you can probably think of another way to do it. Right, so that was my first thought. And take note, I have not done this paper before. Now, write code for a constructor that is going to receive the departure city, the destination city, and the weight of the load. Now you must remember, what are the data types for departure city, destination city? Well, we know those will be 2 strings. The weight of the load, is that going to be an integer or a real number? Well, you have to go and have a look at fload, and in the class definition it says fload is real, so your constructor will have 2 strings and 1 real value. Now your constructor is in the public section, constructor create. In brackets it's got to have 2 strings, s in s destination. I'm just making up some variable names there, strings, and then r weight colon real. So there's your constructor create method header. You write your header and then you highlight it and Control-Shift-C. Let's go and double check. So it's going to receive a city, departure city, destination, and the weight. What did I say? S in, S dep, S dest, S dep, just to be more descriptive. Right, so let us go and implement this method, you highlighted, Control Shift C. Now it's in the implementation section. Well, yeah, there's implementation. So here we've got to go and set our private fields to those things. F departure. Make sure we use the right one. F departure colon equals S dep. The string that's coming in here in that parameter list. That is your parameter list over there. And F destination colon equals S dest. So you're setting the value of the private fields. Then we have, what's the other instruction? Oh, your F load, which is our weight. That will be equal to R weight coming into this class there in that parameter list. So you set the fields, the private fields. F is for the private fields. F departure equals that coming in from that parameter list. Then they have more instructions. Here it says, okay, we've done the first one, assign the parameter values. Then we're going to call the private method compile trip number and assign a value to F trip number to assign a value. So you're going to say F trip number equals compile trip num. So F trip number colon equals compile trip num. So why do we do that? Because compile trip num, we finished writing that method. Where did we write it? There. Remember we wrote that and we said result equals function. So a function we always call on the right hand side of our assignment statement. So our private field is going to be whatever compile trip num returns. Then next thing, set the distance attribute to 0. So we have to make sure we cover all the bases there. Distance attribute, which is here, F distance. There's your private fields there. We say F distance, spelling, we set that equal to 0. So there we set our private fields in our constructor create. Right, just to remind you that OOP is one of the easiest questions of your exam paper if you just follow these rules. Write an accessor method. So what's an accessor method? It is a function, because we're getting things, and it's called get distance, return attribute value of F distance. Only 2 marks. And you must know that an access is a function, and you have to go up here and write the word function, get distance. Now whenever you write a function, you have to have a colon to determine what is the data type of this function. And F distance, is that an integer or is it a real? So F distance is an integer, so the get distance will be an integer function, colon integer, and it's going to return the result. So we have to implement it, Control Shift C. We say result colon equals F distance. So remember that your functions have to return values, and you use the word result, the statement result equals the value that you want returned. In this case it's going to be F distance, and that matches the data type of the function over there. Now we're going to write code for a method called set distance. Now that's quite different, isn't it? That is actually a procedure. Setting, or mutator is another word for setting. Mutator or setting is a procedure, and you write procedure differently to a function. So And this procedure is going to receive a distance between the two cities as a parameter and assign the value received to the distance attribute. Now we remembered that the f distance attribute, remember these attributes are the private fields, is an integer, so this procedure must receive an integer. So we say procedure set distance, open brackets, it has to receive an integer, I, whatever you want to call it, colon integer, and that's how you write a procedure with no colon. Only functions have a data type, but in a procedure, if something's coming into the procedure, then you put that in brackets, just like we did in constructor create. As you can see, there's a similarity there. And we highlighted to implement it, Control Shift C. And now we say f distance, we are setting f distance will be equal to idist. As you can see, procedures are very similar to constructors, except the word constructor is used. Constructor create and procedure work basically the same way, just different names. Right, so we've done set. Now we're going to write a code for a method called determine truck type that will return a one-word description. Now when you see the word return, then you know we're going to be dealing with a function. It's going to return a type of truck that will be used to do the delivery. And description of the type of truck used to do the delivery, light, medium, or heavy. So determine truck delivery, return something, so it's a function, and it's going to return a word description, which is a string. So we're going to work on the load to determine the type of truck. So we must remember that we're using a procedure, no, sorry, not a procedure, because it's returning something, it's a function, and it's going to return a string, and there's no parameters coming into the function. They're not asking you to have anything coming into this method or function. So we will then go and write the word function and determine truck type in our list at the top here underneath the other public method headers. So you have to write your function, determine truck type, and because it's a function we have to have a data type, and in this case it's going to be a string, and we highlight that to implement it, Control Shift C, and now all we do is calculate. We've got to have a either case structure or if statements. Now if you look at the weight, you know that weight is the load. In other words, f load, we're going to work on that f load attribute. It's a real number, so we can't use case with this. We have to use a bunch of if statements, if then else statements. So if f load equals something else, if f load, so I'm going to start with the first one. If f load is less than or equal to 1,000, then the result will be light truck. Else, if f load is between that, you know those two values, then we return medium truck. Else, we will return heavy truck, because anything else will be a high number. So if f load is less than or equal to 1000, then result, remember whenever you say result, that's the end of that function. Else, take note, no semicolon before else. So whenever you say result, that means you're now at the end of the function. If f load, now we're going to have a range here from greater than 1,000 and less than and equal to 5,000. Oops, sorry. Oops. So if load is greater than 1,000 and if load is less than or equal to 5,000, then result equals. Now in Delphi you have to, if you have two conditions like this, then you must put them in brackets, separated, and I'm using and, I won't use or because then you're going to have every single number. Then we'll say result equals medium load. Take Gr12, I use copy and paste. And of course I didn't spell wrong right there. And all you have to do then is say else the result is a heavy load. So that's that. And you don't need a semicolon before end, and you definitely must not put a semicolon before else. There's your nested if then else statements, and when the processor hits on result, that will be the end of the function. That's why we have to have if then else, if then else. So I'm just checking that it compiles before moving on. So you run your program if you want to check that it compiles. If you don't have time, don't worry. Now we're going to go move on to 3.2. This is implementing our class. In other words, using that class definition. And the very important first thing to do, and we know that this must take place in the main program. Take note, everything that we did so far was in our class definition program. You will really confuse yourself if you go and put all of these things into the other program. This is the main program. That is our class definition. Make sure you differentiate between the two. We're now moving on to the create trip button, and which is 3.2.1. We're in the main program. We've got to create the object class display information, so we're going to see write code to do the following. Instantiate the object using the values obtained from the components, from those radio group box components and the edit box. So yeah, we've got to go and quote RGP question 3 point underscore 2 underscore 1 underscore departure. That's a mouthful to type. So the item in .items .item index. Well, to make your life easier, let's just make some variables here. VAR S. Yeah, I don't want to use the same strings I used in the class definition. S destination departure. And what is the other one? It would be the load kilograms. So these two are strings, and then the other one is a real R load, which is the same as the weight, but we're going to use the word R load here. Then we go and give our string some values from the input components. In this case, they are called RGP question 3 underscore 2 underscore 1 underscore question 3 underscore 2 underscore 1 underscore destination dot items square brackets. Did I write that word right? RGB question 3, sorry, RGP items, and then you've got to quote the item index of this in square brackets. So this is a bit of a trick, but people don't realize that this is how you can get hold of your string, the string that's associated with the radio group option that is chosen by the user. And yep, it's a mouthful, but it's a quick way to do it. Otherwise you have to do a case item index of. That also works, but this is all in one line, so it's quicker. And same for the other one. So take note, you want to get the JHV or DUR and so on of the item index that they chose. So typically maybe you'd use case RGP.item index of, and then 0123, 0123, but a quick way to do it is like this. So use your quick way, and I'm going to try and be even quicker and copy and paste this and put the right radio group box name in there by using my auto sync auto mode RGPS departure. So remember, it's dot items and in square brackets the item index of that same radio group box, and this works with a combo box and a list box as well. The same concept. Now our load got to be string to float, and in brackets we're going to put in, what are we going to put in? EDT question 3_2_1 dot text. Now they're not asking you to check if it's a real number, so you don't write code to do that. If they wanted you to check that it was a real number, they would write here to tell you to do that. Right, display the object information in the output area, RED question 3. So first of all we have to instantiate that. We've got the strings from the input boxes and the real number. So now we've got to instantiate an object called obj trip. There it is, obj trip. It belongs to that T delivery trip that was defined here in this unit. Okay, so we get obj trip, and this is also something that you tend to forget. Obj trip colon equals T delivery trip dot create, and in open brackets you put in order, we've got to put the destination. You know, can you see those little tooltips that come up? Because this class is defined properly and there's no syntax errors. But if there were syntax errors in this other class here, then you wouldn't see those things. Then you need to know what is the order that there must be. So you take the local variables that you defined here in this button click event, and you go and put them in here. S destination, comma, in the order that it occurred in constructor create, that order there. And S, what was first? First was departure, not destination. S departure, S departure, comma, then destination variable, S destination, which comes from here, and then the last one is R load, the variable over there. So you make sure that they're in the same order, S destination, and the weight, and in this case the main program I'm using R load in this button click event. So we instantiated the object successfully. Now we are going to display the object, and guess what, we go and look at our class definition for our toString method, which was already written for us. There it is. Often you have to go and write or finish writing this toString method, but they've already written it here. It is provided code in this class definition. toString, it's a function, so we have to either call it on the right hand side of the assignment statement. We're in our main program now. Functions, you know, it's always on the right hand side of the equal sign, or in a rich edit.lines.add statement. And in this case we have to display it into red question 3, which is a rich edit. So we say red question 3 dot lines dot add in brackets. Now if you want to call the object, the toString method, we have to quote obj trip, and then we say dot and then toString, and there we have it, finished. So there's that one done. 3.2.1, we've got 3.2.2 now. Right, so information for each city of departure, destination, distance stored in a text file. The format of each line of text file is departure, destination, and distance. Fine, there we're showing to you. Extract the distance between the selected departure city and destination from the text file. Now, we have to go through every single line of the text file and put the strings into a variable, and then copy from that variable. Each going to read from the text file. So you do have to write code to read from a text file in the next button. This 2.2.3.2.2, and they've written code for that. So now all you have to do is make a text file variable, var t file text file. I'm also going to make a string s line string. We always do that when we want to read from a text file. We're going to put our code in the right place. We have to use a sign file statement, and we'll say t file comma and dot and question 3 dot txt. Take note that when you quote a text file name or an image or anything that you're going to refer to, then you've got to use the right uppercase letters if there are any. Right, we're reading from, so we use the sign file statement, then we reset our text file for reading, and then we use a while, not end of file, t file. This is standard text file handling. T file do, and then we go and begin and end, and we're going to read from read ln from t file into s line. And what are we going to do with s line? That is the magic question. Get the distance. So we've got to copy from there to there, between the selected departure city and the destination city from the text file. Set the distance of the object to the distance extracted from the text file. Display the distance and use a toString method to display updated information. Now, each city departure and destination between the cities stored in this text file. So if we had to go and look at our interface here carefully, people are going to choose a departure city and a destination city. They're going to enter their load. So now that is, you have a certain departure city and a certain destination, and in the text file we have to go look at the departure and the destination, and then we have to set the distance. So what we're going to be doing is going through each of these lines to see if the departure that was chosen by the user over there and the destination chosen by the user, if it matches these two, any line here. So one of these lines have to match the departure and the destination. And we're going to do that in code. We've got to go and get our destination, get our departure from each line of the text file and see if it matches the departure and destination that was chosen by the user. But in our delivery trip info, we have a method called get departure, so we can see which departure was chosen, and we will be able to get destination as well. So get departure and get destination, these are methods that were already written for us. We had to know that they were written for us. We're going to go and get it, the one that was chosen by the user, get the departure chosen, get the destination chosen, and see if they match, and then from the text file read off what the distance is, and then we're going to set the distance using the set method, the procedure set distance. Okay, so let's do that. So we're going to copy, we'll have some variables over here for strings, s departure, s dest, those are strings. We also got to get our I distance colon integer. How do I know I distance is an integer? Well, every line of this text file, those numbers at the end are integers. I don't see any real numbers there, so we safely, and also the class definition, private field f distance is an integer. So let's go, and after we read from each file, we're going to say which one comes first in the text file. We have to remember that. What comes first in the text file is the departure. So sdep colon equals copy from S line from 1 to the pos of the comma in S line, comma there, and -1. So this is standard copying from the text, from a line. Copying from position number 1, number of characters will be equal to all of this, which is the pos of the comma in S line -1. Look at the text file, so you would copy from 1, which is the J, to the position of the comma, but -1, because then you'll have those 3 characters. Then we're going to delete. We can safely delete all of that because we have copied it now, and we want to delete the comma as well. I don't need that copy thingy over there. Let's go. Then we're going to, oops, semicolon. Then we're going to go to get the destination s dest will be equal to, and I'm going to copy again, but this time it's going to be the hash, isn't it? I'm going to copy up to the position of the hash -1. And why I say hash? Because the destination is those 3, and we go to the hash. And then we delete that, everything, and the hash. And I'm going to copy and paste this line. And that will be our hashtag. And then all we have left with then is, oops, I forgot to close my bracket here. Double check your brackets, people. We'll have R load. Is this my variable that I made here? No. I distance. I dist will be equal to string to int S line. Whatever's left of S line that is what will be, that will be the number at the end after you've deleted the hashtag and the comma. So up to the hashtag and the comma. Right, now all you have to do is go and check. Ask the question, if step colon equals obj trip. Why am I saying obj trip? Obj trip is my object, equals the obj, is it called obj trip? Yes, it is obj trip. If, oh yeah, there mustn't be a colon. If step equals obj trip dot get departure and s destination equals obj trip dot get destination, then, well, what are we going to do in begin and end? Take note, this is all happening in that while loop to read from the text file. But before we go any further, don't forget to put brackets around these things. Very important. If that is equal, and that is equal to that, then we are going to set our distance. Of course, set the distance attribute extracted from the text file, and we'll display the distance in the edit box, and so on. So, yeah. The question is, are we going to do it inside here? Inside our while loop? Well, we could. We could do it all inside here. So anyway, we have to say obj trip dot set distance. Now why am I just saying obj trip? idist. I am, because I'm setting the distance, I'm using the procedure over here that we wrote, procedure set distance, and I'm using idist to set the distance for this particular object. Yes, I will go and display it in the text file, in the edit box, edt question 3 underscore 2, display the distance in edt question 3 underscore 2 underscore 2, and when we want to display the distance, we can go and use the object called, the function, sorry, we go to the object and you've got to use the function called get distance to display it. So we say what is the edit box called? edt question 3 underscore 2 underscore 2. Okay, edt question 3 underscore 2 underscore 2 dot text colon equals, we want to get the distance, we set the distance using our class definition, and now we're going to get the distance as well. We say obj trip and get distance dot get distance. Get distance is an integer function. The get distance here in this class definition is an integer function, see? So we have to go and put this whole thing int to string. We've got to convert this to string. What else must we do if you find a match between the destination and the departure? Use the toString method to display updated information of the object in RED question 3. So RED Q3, we've got to go and use the toString method. RED Q3 dot lines dot add a rich edit obj trip dot to string. So one valuable thing to remember is that after you have used constructor create here in your main program, see this is the main program, after that you must always use obj, the object name, to do things. Obj, obj, obj. And you must use the methods here in the class definition to do them. You just have to remember if the method's a function or a procedure, and remember, well, you've got to go and have a look if you don't remember that the function, what type of function it is, an integer or string, and also if it's a procedure, remember what parameters they are. And if you remember that procedures are used by just writing the word, the procedure word, you must put in the obj object name in front with a full stop. So that's what we're doing. Now there's just one other thing here, of course, and that is you don't want this processor to be overworked. You want the processor to not have to go through every single line of the text file. So maybe we can stop the loop of reading from the text file by using a Boolean flag. While not end of file t file and b found equals false, do begin and end and set b found to true so that the loop will stop when we find a match. So if we find a match of the departure and the destination, set b found to true. Now, so while it's false, it'll carry on, but we have to make sure we set it to false beforehand, before the loop. So I'm setting it to false. We don't want the processor to overwork. And then, of course, declare it as a Boolean variable. And there we have it, all done. Now I'm just going to run to make sure I don't have any syntax errors. And so it is, and just to triple check, create that, and determine and set distance, and there we go, fixed. Right, now let's do quest by magic, it all works, see? Let's go to 3.2.3. Call the relevant method to determine the type of truck and display the results. By that, use question was 12. This is 2 marks. So check your number of marks, guys. We're going to use the objects of the class, determine the truck type. Now, yeah, you might say, oh, what on earth? To call the relevant method, and you've got to use your obj trip, and you've got to go look at this and determine truck type. There it is, function determine truck type. So it's a string function, and we are going to put the result in where? Remember, functions return result, edt question 3 underscore 2 underscore 3. So we're going to write edt question 3 underscore 2 underscore 3 dot text colon equals, and it's a function obj trip dot determine truck type. And there it is. So if you know it's a function, it's going to go on the right hand side. You know you've got to use obj trip, and you know you've got to go and put it in the edit box. And there we go, folks. It is complete. So determine truck type, median. Right, so I'll see you for the next one. Cherry bye.